So the next little piece that we're going to get into are items that are kind of overlapping from the C# 8 world and the .NET Core. So because the C# is really how we code in .NET Core in a lot of ways, or how many of us do, there's things that if you add something to C#, you have to add support for that to .NET Core. And so we'll talk about a few of these things. I kind of picked out the ones that I thought were the most interesting. The first one is a new concept called indexes and ranges. And this is a way, and I'm just going to show you the code. It's going to be a little bit simpler to just look at the code. So here's my test. By the way, this project will be available. It has a bunch of unit tests to show a bunch of the different features, and it also has a DB context. But I did want to show you this. I did just upgrade Visual Studio while I was standing back there about a half hour ago. So that way if things go wrong, it's just the fault of Visual Studio. But if you look at this and you run, Mark said this, analyze code coverage, like check this out. This is about as good as it gets. So I don't think I've ever had a program that was like this before in my life, but this one actually has really good test coverage. So here's an array, just 6-element array, bunch of integers. And have you ever wanted to say, I just want the last item in the array? Or I want the third to the last item in the array. And it's like, okay, figure out how many things, index, length, minus, is the length the number of elements, and so I have to subtract a certain number. So this makes it really easy. So if you want the last element in the array, it's just this syntax. So you use the _1, that just means last item. _2 is second to the last item. So in this case, it returns a 4. So pretty nice. Again, are you going to use this every day? No. But when you need to get to the last item really quickly, it's way better than writing arr.length -1 and put that in brackets. This is just a way simpler way to do that. Here's another, and here's a couple more examples just going after these. Now this is a little bit weird. It took me a second to wrap my head around this, but if you notice, the last element is what? _1. What's the first element of an array? 0. Okay? Now, _0 throws an exception. Okay? So it's 0 based from the beginning and kind of 1 based from the end. And so you just have to put that in your head and say, this is how this works. Now, it makes a little bit more sense once we get into the ranges, because it's a little more clear why it's that way. And Mark's going to make a comment here as I'm talking bad about C#. So it seems interesting. So what, this one here? That's a great question. I'm going to let people that really care about that stuff answer it.
So the index operator translates in IL to a new index data type. Data type that takes an integer value, Boolean for count from the left or count from Boolean for count from the right. So it just takes those two values. If you put the head operator in IL, that translates to a new index value 1 counting from the right. And it is an operator, but more accurately, it's a new way, it's a new literal. So we've never had a new literal introduced in the language since C# 1.0. It's actually a new literal. It's a new way to express an index rather than saying new index. It's actually literal, just like when you express a string with quotes, blah, 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 quotes. That's a literal for a string. This is a new way to express a literal for an index, and then similarly, we're going to show you for a range.
So it is more performant than array.length -1.
It is more performant than array. It is because you have to do a calculation.
Somebody has to do it.
I would say it's similar performance.
Yeah, you still have to do it.
What's interesting about it is you could write your own collections that work with the index operator. And so there's another thing to think about. The reason why it counts from 0 is it's essentially trying to mimic what you would do if you did length minus. So the way to remember this is if I was going to do a length minus, then operator that has a hat before it, that 1 is because you did length minus 1. It maps into that value. So this is more of a memorization.
Yeah, it is. You just
think about it conceptually as a length minus 1, and that allows that 1 is the last element in the array, the 1 after that. And I'll let Grant explain range, because that's where it actually...
right. It kind of starts to make sense. Yeah, so it does make sense.
That's one way to memorize it. So the 1 minus the length of it.
Right, so here you have a range, and again, some new syntax with the dot dot, and being able to say, grab this set, so that's going to grab me 3 of them, again from 0 to 2 in this case. And if you come down here, this is where it gets kind of interesting. If you do this, whenever you use the hat, right, it's going to count from the right, come back, but it's exclusive of the last item. Okay, so
the range operator.
right. Sorry, when you use this, so 3 dot dot from the right 0, it's going to actually take the whole all the way from the right. If I put a 1, it doesn't take the last item. So it always excludes. It's inclusive of the first, exclusive of the second. And so so you get this. And really, I'm not going to go in and spend a ton of time on this, but if you look at the examples, you can kind of see I tried to walk myself through all these things. That's why I wrote all these tests, so that I could go through and understand how does this work in all the different cases. And so you kind of get an idea of how do we do this. And you can see 2 different ways this is done. Here, I'm going after it and putting it in line right inside of the array. And instead of pulling out 1 item, I'm going to pull out essentially a slice of that array. And here, I'm creating a formal range object with this syntax, and then asking for the range here, and it's returning it. Essentially doing the same thing. One is really just inlined, one has an object that we're creating. Okay, any questions? Range index? Helpful?
When did the Ruby guy stage a coup?
It feels like everybody is copying from everybody these days, which is kind of cool. I mean, I see a lot more convergence than we have in the past, where people don't feel like what everybody else is doing is horrible.
It also seems like R or Python, when you look at the index, one of the different ranges within.
Right.
The difference being that this is a data type, and it's not a data type in Python. Like in Python, it's actually an operator that compiles that to something else. In this case, you actually have a data type that you can modify and interact with, and none of the other languages support that.
Cool. Anything else on that part? This just really quickly covering this async streams to be able to await a for loop without having to do some other. There's other parallel fors that you can do. This just gives you a nice simple way to do that, to be able to yield results as they come back. There's some good examples online. I'm not going to go into much detail here. Again, not a ton of detail, but they did update. Who's used floating points before? How many people think floating points are the devil? If you don't, you just haven't used them enough. Use decimals if you can, because they don't have the same kind of errors. But as you know, floating points, they eventually have rounding errors, because it's not really that number, it's just something close, because it's a certain amount of stuff and then some exponents, and you get into rounding problems. And so IEEE came up with some standards as far as how this should be handled to minimize rounding errors. Well, that wasn't exactly how .NET Core was written, and so they have modified some of those things, and they've actually added some things like this. I thought it was really clever, like this bit increment. You can take a double and say, I want to go 1 bit larger, and it'll give you that number, or 1 bit smaller. And so you can see exactly what the precision of your numbers are and how much they're changing with just a single bit of your float being changed. So again, I'm not sure how useful this was, but when I was looking at it, it's like, oh, this is pretty interesting. And there's like the max magnitude and stuff like this. I think they're just some shortcut ways to get around doing some things that can be problematic when you have very, very large or very, very small numbers dealing with positives and negatives and things like that. Again, it's just really compliance with this IEEE standard. So I just wanted you to know, because if you work with doubles, if you work with very large, very small, this may really help you. And there's a bunch more of this stuff. Yeah, go for it.
Interesting story. We actually had some source code
Because of this?
Because of this.
Oh, because the doubles.
We actually contacted Microsoft, and it was a bug, but it was part of what was supposed to be.
Yeah. It has, so the results of the functions dealing with floats, again, at the extremes, will be different. You will have different results because the rounding errors that used to be there are still there, but they're not as great because there will always be rounding errors with floats. And instead of floats, you're going to use a decimal. Okay, great. Just make sure we're all good on that. That you want to increment, right? No, right. No, it'll increment. Yeah, a double number of bits. That's super helpful, isn't it?